Good morning. So we are back and we are in a brand new book called Looking for Pythagoras. This whole unit we're going to explore the Pythagorean theorem and how it applies in everyday lives and distance and coordinate planes and objects and all sorts of stuff. So today's going to be very basic. This week will be very beginner level basic. Feel free to pause me and copy down these notes right here. We're going to be using this the whole way through and taking it apart piece by piece. So first thing first is the Pythagorean theorem is simply a squared plus b squared equals c squared. The a and the b are always the legs of the triangle. The c is always the hypotenuse. More particularly, the legs always form the 90-degree angle, because not every time will the triangle be looking this way. It might be turned upside down or faced at a weird angle, but you got to know that the two legs that form the 90-degree angle are always the a and the b, and the c is always the longest side of the triangle. That's a fact. Of a right triangle, that is. Another thing, it doesn't matter which one you call the A or the B as long as you know they are both the legs. Now, this is a direct introduction for today. It's some questions you're going to see. I'm going to do these. I'm going to do a couple more examples, and then that's pretty much it for the day. So, first things first. Very literally, and I don't want to insult your intelligence because I know you know this. If it wants to know if we're driving, because you're doing this thing where you're driving in a park today, or you can fly from A to B or from A to C or from B to C. If you're driving, you have to stay on the roads and you have to go on the left and right, north, south, east, and west. So if I were to literally ask you, what's my driving distance from A to B, I would say from A to B, I would just say north 2 blocks and east. Make sure you guys use cardinal directions today. East, a total of 1, 2, 3, 4, 5, 6. Okay? And again, if I were to ask you what is my driving distance, or what is my driving distance from, I don't know, B to C, all right? From B to C, you're literally just going. You can either go north, or you can go north or east, whatever you want to do. First, doesn't make a difference as long as you get there. I can go north, we'll say north 4 blocks, and east 4 blocks. It's that basic. All right, that's some of the questions you'll see today. It's that basic. Make sure you guys understand that. But now, what if they ask you guys to, what is the distance from A to B if you're flying there in a helicopter? So here's where you got to get a little thinking outside the box. If I'm going from here to here, right? Remember, this is on a flight path, so I'm going over the roads. So we can't just assume what this distance is. You have to use the Pythagorean theorem. Now, I can either use Pythagorean theorem like this, looking at this as a right triangle, that way, or I can look at it like this, going up and then over. Either way, I'm going to have my legs, and my legs are going to be the same no matter what. So this is one leg right here, and this is the same as this leg right here, and that leg happens to be 6 squared. That's my A, doesn't matter if I call them A and my B. And this right here is my distance of 2. 2 squared equals c squared. Now, the next thing you do is just do the math. And you have to do 6 squared, which is 6 times 6, which is 36, plus 4 equals c squared. And last one, no, not second to last but not least, you got 40 equals c squared. I would square root both sides because that is the inverse of squaring something. So this is going to equal, because a lot of your work today is asking you guys to answer this in tenths. So let me see what this equals. 40 square root of 6.3. Okay? 6.3. Now, that is that for just the estimated answer. We're going to learn later on how to find an exact, precise answer. I'll do another one right next to it, okay? I want to know what my flying distance is from A to C, all right? So I'm just going to do this. I'm going to go up all the way to 4, and then all the way here. And now I can figure out my exact flying distance because I've made my 90-degree angle. And again, it doesn't matter what you call your A or your B, just call one of them, okay? So I'm going to do my distance here is 2, 4, so I got a distance of 6 squared plus another distance of 6 from here to here, 4 from here to here, so that's 10 squared, equals my c squared, which is we're finding the hypotenuse length right here. So this is going to be 36 plus 100 equals c squared. 136 equals c squared. And then second to last but not least, we're going to square root both sides, and the square root of 136 should be a little under 12, because I know square root of 144 is 12, so 136 square root of 136. 11.66, so that means it's 11.7, because some of your directions today ask you to round to the nearest tenths, and that is good enough. I'll be back in a couple seconds with some more examples. All right, now my last examples are right here. Now I actually know my C in both of these, and remember, you always start with your formula in this first investigation so you guys get it memorized, okay? And the whole point of this is so that you rewrite your letters with what you know. Well, I don't know my A or my B because I know this is either my A or my B because it attaches to my 90-degree angle. That's how I know it's one of the two. And I don't care which one you call it. It doesn't make a difference at all. So let's just leave it as A squared plus B is now 3 squared equals 5 squared. So that's the first thing you do. Next thing, perform the math. A squared plus 9 equals 25. Subtract 9 from both sides, you get A squared equals 16. And the last thing you do is you square root both sides, so the A equals 4. Square root of 16 is 4. Now over here, let's see what we do here for this one. So again, which one do I not know? Well, I don't know my A or my B. All right, well, let's call that my B, because who cares if we call it either or. So my A is now my 9 squared plus B squared equals 20 squared. My 9 squared is 81 plus B squared is B squared plus 400. I subtract 81 from both sides. B squared equals 319. This will be some messy number, which is fine. Square root both sides. B is going to equal square root of 319, 17.86. So 17.9 to round it to the nearest tenths. And that is that. All right, my last example for you is how to use Pythagorean theorem to see if right triangles are in fact right triangles. So let's just do the math and you plug it in to see if they add up to equal what they're supposed to equal. So if that's the case, I got 9 squared, because this is my A and my B, plus 12 squared. So if my left side equals my right side, it will in fact be a right triangle. And this is 225. So when I add 81 to 144, I get 5, 2, carry the 2, 2. So look at that, 225 equals 225. So yes, this is right. This is a right triangle. I can't just draw a right triangle and assume it's a right triangle with the lengths given. I have to prove that it's a right based on this first test, which is, does it satisfy the Pythagorean theorem? And because when I add 9 squared plus 12 squared, and I get 225, that is equal to my hypotenuse, boom, we have a right triangle. Let's test this one over here. So 7 squared plus 6 squared equals 10 squared. So I got 49 plus 36 equals 100. And 49 plus 36 is 5, carry the 1. I got 85 does not equal 100, so no, not a right triangle. This is what we're doing today. See y'all in class.